What is up, fellow game developers? My name's Tyler Potts and welcome to Muddy Wolf. This is a different video to my usual devlogs. I wanted to take some time out instead of showing you what I'm making to teach you how to make the game we're currently making in my devlog. So if you want to see this game, the behind the scenes sort of devlog, then go check those out on the channel. But in this video, we're going to be making this power bar sort of shoot your character, drag and shoot to get some sort of velocity. As you can see, we just fire it into the portal and bam, there we go. So that's what we're going to create in this video. So sit back, grab your snacks and let's go. Okay guys, let's get into it. I've opened up Unity Hub here and I'm going to create a new project. I'm going to select 2D and I'm going to name this drag and shoot. So I'm going to click create. And it's going to load up a Unity instance or Unity project and we'll wait until that's done. Okay guys, so the project's opened up and the first thing I'm going to do is shrink this because it's very big. And I'm also going to bring this down a little. But no, first things we're going to do is we're going to go and I'm going to drag in some assets, basically some very basic shapes into my assets. No, come back here. Come back here. Drag and drop into the assets folder. There we go. So let me just show you what these shapes are quickly. They are basic shapes: a square, circle, triangle and hexagon. We're only going to be using the square and probably the circle in this video, so you can create these very easily. I don't know if I should put them in the description so you can download them because they are very easy to make. But it's up to you. Anyway, I'm going to make this 256 and I'm going to set this to multiple so we have multiple sprites because we do. And I'm going to go to the sprite editor, I'm going to click apply and this opened up on the wrong screen again, twice. Let's make this a little bit bigger and can I zoom in a little? There we go. I'm going to click slice and we're going to select automatic center and click slice. Now, if you click on the screen, you'll see there is 4 different slices which match the different shapes. Let's click apply. And once I apply, let's close that. And now let's open up our shapes and you can see we have different shapes. I'm going to drag in a square. I'm going to make it set on the 0 and -4. And I'm going to make the X equal to 19, 18. Yep, and the Y equal to 2. I'm then going to set this to -5, and that's perfect. So that's just going to be our ground. I'm going to add a box collider to this 2D, and what that's going to do is allow our object to collide fit, so our object doesn't just fall straight down into nowhere. So let's create a circle now, which is going to be our object. Let's drag it into the scene, anywhere will do. It just annoys me. Let me just reset that to 0. There we go. And let's add a circle collider 2D on this shape because it's a circle. We also need a rigid body 2D to add some forces to it and to be able to apply forces. So we're adding that and this will apply gravity. So if we click play, our circle is going to drop straight down onto the platform. That is the rigid body causing the gravity there to kick in. Let's come out. So we have our rigid body 2D. Check. A circle collider, check. And a ground where we can sit on, check. That's great. We now need to create a new script and we'll call this the drag and shoot script because obviously this is, you're going to drag and you're going to shoot. That's what's going to happen. So I'm going to double click this to my computer first. There we go. Double click this to open it up in Visual Studio. I was about to say Visual Studio Code, but this is just Visual Studio. So let's remove the starting items in there. And we're going to create a few different elements. We're going to say public float power is equal to 10F. So this is our first variable and it's going to be the power of the force we add to our circle when we pull back and let go. We're going to multiply our we're going to multiply it by power. So we have that. We also need a reference to our rigid body 2D because that needs to be 2D. And we're going to call this RB to stand for rigid body. We need the rigid body 2D so we can apply forces to our ball. So let's save that. I'm going to go back to Unity quickly, and I'm just going to rename the shape 1 to ball, just so we know. Save, and you're going to see down here we've got 10, and we can apply the rigid body 2D. Perfect. So we can go back to our script now, and we can now go in and add a couple of variables. We also need a variable called, we need a vector2, and we're going to call this min power. We're then going to need another vector2, and we're going to call this max power. So this is going to clamp our, we're going to use these values to say this is the max power we can draw back, and the min power we can draw back on our x and y values. So obviously, if we, depending on different screen sizes, if we dragged all the way back from the top right to the bottom left, that's going to give us the maximum power we could possibly do. But if we limit this by using a min power and a max power, that means we can, even if we drag from the top right to the bottom left, it's only going to max out at a certain power. So you can't just win by having a bigger screen size. So once that is done, we're going to then create a reference to our camera and call it cam, because we're going to need to get our, we need to convert the mouse position from a screen position to a world position, but we'll do that inside the script. So we've got our camera reference, and I think that's, we need a couple more. We need a vector2 called force, which is basically going to be the force we apply by calculating our 2 points. Yeah, so we're going to use the force, we're going to apply the force, and we're going to multiply by the power to give us the force we need to add on to our character. We're then going to get a vector, that's not a vector, that's a vector. We need a vector3, which is called our start point. We then need another vector3 called our end point. And these are the 2 points. This is the start point from where we first click, and the end point is where we drag to and let go. So that is how we get those 2 points. We now need a start method. So I'm going to do start, and I'm just going to set the camera equal to camera.main. And this is just going to grab any, the first camera object it finds, which is attached to the main camera tag, or is tagged with the main camera. So back to the script, and that's all we need in our start. So start is called as soon as the drag and shoot is ready. And then we're going to make an update function, which is called every frame. So each frame per second, this will be called. Now we need to set up a few things. We need to get some inputs. We're going to say if input.get mouse button down 0, which stands for the left mouse button. We're just going to debug.log right mouse button, just so we can test it's working. So let's go into our scene here. Let's click play. And if you look at the bottom left corner and I click, you'll see it said we pressed the right mouse button. If I left click, you'll see nothing actually happens. And we only have the one log on our screen because it was only called once and not twice, which is perfect. So that's how the script is working. But we want to get the position. So when we first click, we want to set the start point equal to a new vector3, or, well, firstly, let's just say cam or input.mouse position. Now let's just debug.log our start point. You can see what's happening here. So let's go back in here. Let's click play. And if I click here, you'll see it says we're at 647 on the X and 360 on the Y. Now you're probably thinking they are huge numbers. When you drag and pull and add a force, that is going to apply a huge amount of force. And you are correct. And that's because these are pixels. These are in the pixels of the screen. So the further I go along here, if I click in the bottom right here, it should apply near enough to 1920 because I'm on a 1920 screen. So that is not what we want. So I'm going to unpause or unplay that. And basically to fix that, we want to say, or I want to keep the start point, but to fix that, we want to say cam dot screen to world point, and we're going to pass through this. Now that is going to transform it into the world point. If we hit save and we go back in and we play again, this time the number should be considerably smaller. So this is 0. So right here is about 0. As you can see, it's 0, 0.7. If we go to the top right, that should be only about 8. Yeah, 8 and 4. And if we go backwards, you'll see it's minus. And that's because this is the world point and this is the dead center section. So now we're getting a more accurate in-world points. But one issue we're going to run into is this start point when we click, it's going to have a -10 on the Z axis, which we don't want. So there's enough way to fix it. We can say start point dot C is equal to 15. And that now I believe that should set the start point to 15. So if we say debug.log and we can say start point, we should now see that so as you can see down there, it was -10 in the bottom left corner. But now if we click, it's now 15, which is perfect because basically we don't want it to be equal to -10 because else it's going to hide behind elements in the scene when we start to add a line. So in my tutorial or at the beginning where I clicked and I dragged and there was a line, that would be disappeared if it was -10. So that is how that is working. So we've got the mouse down, which is perfect. We now need to get when we let the mouse up. So if we say input dot get mouse button up, and again we do 0, this is now going to say when our mouse button we pull up, we want to set the endpoint equal to, again, the same cam. So we actually just want this. And right here. There we go. But we want to set start point to be also endpoints. We also want it to be 15 and not -10. There we go. So that is now correct. And we can now set our force. So our force is going to be equal to a new vector2. And we're basically going to say, I'm going to drop this down, I'm going to say math f.clamp. So we're basically going to clamp our values between 2 points, which we did earlier. And I'm going to say start point dot x minus endpoint dot x, and that is going to clamp our points between each other. And then we're going to give the min power. So we set up a variable called min power. We're going to set x. We're then going to also say max power dot x. So that's our 2. So that's 1. That's our 1 math x. That's just for the x value. We're now going to say math f dot clamp again because we need to set our y values. And in here we're going to say we're basically going to do the exact same thing. So I'm going to copy this and I'm going to paste this into clamp, but we're going to change all this to y. So the y values of all our things, which is perfect. We're also going to do something here, which is going to basically fix some issues. So if we change the orthographic size for our camera, we want to basically divide by that. Actually, we don't, because we're not going to be changing our camera, so we won't go into that. Now we've got our force, we basically just want to say rb.add force. That's not force. Add force, and we want to say our force times the power we set, and then we're going to say force mode 2D to impulse, because we want to add an instant velocity to our rigid body instead of just a incline force. So now we've got that, we can go back and we need to set up a few variables. So let's click on the ball variable down here, scroll down, and you can see we've got this. So we've got it set to 10. The min power is going to be 0, or actually it's going to be -8. That will allow us to go backwards, and -8. And the max power is also going to be 8. So if we save and we click play, we should now be able to drag and let go. Oh, and it's gone. It's gone. It's gone far and wide. That ball's gone. Maybe we should lower this. Or maybe just the power should go down to probably about 5, maybe 2. I don't think it needs to be any bigger than that. You can adjust the values to match what you want. So if we drag and we launch, there you go, you can see. And that is it. So if we drag straight down, we'll go straight up. Oh God. As you can see, the ball flies around. And let's bring it back down. There we go. I don't know if this F is going to stop. There we go. So, oh, well, we can stop the game anyway. Cool. So that's now applying the force. So that is the basic concept for drag and shoot. Now we can set the max power to be even lower. So if we said the max power should just be 3 and then -3 and then times it by 2 and we hit play and we drag and shoot, you'll see the power is a lot less. And if I drag really far, that is literally the max power we have. So we can adjust those to be how we want the rigid body to be. So now I want to show you how to, when you click and you drag, to apply a line between the 2 points. So to do that, we need to create on our ball, we want to add a line renderer. So we're going to say line renderer. We're going to apply this on, and it's going to be here. We're going to set so if we set the positions here, you'll see there's enough. When we set to 10, you can see there's this pink line that goes through. And it's very thick. We don't want it to be that thick. I'm actually going to set it to be 0.5. But then I'm also going to set a second one. So I'm going to double click in here to create a new point. And you can see I create this like divot. So I'm actually going to flip these around. So I'm going to make this one a lot smaller. So about 0.25, which is here. And I'm going to set this one to be equal to 5. So the bigger one is coming down. I'm actually going to say it's a lot smaller. About there. There we go. So it'll look like when we drag and we pull. Now, I'm actually going to apply a material to this, which is on my other screen again. And this is just going to be the sprite default. Or actually, maybe the line default. I don't know if there's any difference. There is no difference. So that means we can apply colors to this. So I'm going to open up the color gradient editor, and I'm going to click here, and I'm going to set the alpha to 0 because I want it to go to be invisible. Now it's looking a bit weird there, but that's because we're going the wrong way. If we would set this to 0 and this one to 10, it'll be the right way. Oh, or will it? So we actually want to flip these round, so it's like that. That makes more sense. So now they're going the right way. I'm also going to add a cap vertice of 5 to make it a rounded edge. Or actually, 1 makes kind of a triangle, not 51. 1 makes this triangle effect. Although, it's reset this. So let's bring this back down. There we go. So we've got like kind of a point, which I kind of like. And we'll also need this use world space to be on because we want it to be in the world space and not attached to the ball. If we turn this off and our points was, let's say it's F0, we said 5, or we move the ball, you'll see it moves with it, which is fine in some cases, but we want it to be using the world space. So now when we move the ball, it doesn't actually affect the line because that could get confusing. I'm going to set these positions size to 0, which is basically going to remove the line for us so it's not always appearing. And now I'm going to create a script called line trajectory, to call it trajectory line, maybe. Trajectory line. And let's create this script. And let's double click it to open it up in VS Code. Now, in here, we just want to remove these again. We'll probably need them in a minute, but we don't need them right now, so they're gone. We want to say public line renderer, LR, and then we're going to say void awake. We want to say LR is equal to get component line renderer, and that is going to get our line renderer. We actually want to go up here and say require component type of, and we're going to say line renderer. So this is going to require a component of line renderer before this class is initiated, which basically means this will never fail, because sometimes on awake you could awake it before the line renderer has awoke. So we've got that. We now want to create a function called public void render line, which is going to take two arguments, which is going to be two vector frees. The first one is going to be called the start point, and the second one, if you can guess it, is going to be called the end point. And these are going to be the 2 points we create. So when we call this function, we want to say lr.position count. So if you remember, I set the position count on the ball equal to 0, which made the line disappear. We now need to bring those back. So we're going to say it's equal to 2. We then want to create a vector-free array and say points. And we're going to say new vector free, and we're going to pass through a 2. So there's a new vector free array, which is going to have two it's going to have 2 points available in it. So we're going to say points 0, because they start from a 0. So then we're going to say equal to the start point. We're then going to say points 1, and we're going to set that equal to the end point, and that is all we need to do for the points. We now need to set the position. So we're going to say lr set positions, and we're going to pass through points, which is basically going to add in the 2 points for us. We now want to create one last thing called public void end line, which is basically going to, once we've dragged and shot, it's going to, well, actually, we'll do this after so we can demonstrate it. So we've created this line, but we need to go into our drag and shoot script and basically call this function. And to call this function, we need to say, so we've got the mouse down, which is fine, but now we want to say if the mouse is held down. So we're going to say input dot get mouse button, and we're going to set that equal to 0. So this means if the left mouse button is down or just held, then run this script in here every frame. So we're going to say vector free current point is where we're currently dragging our point to, and we're going to say is equal to, and basically we just want to grab this code right here again. So we just want to change it to current point dot set is equal to 15. Now all we want to say is tl dot rend. We actually need to get a reference to our line or trajectory line, which we're going to call TL, which the script is going to be on here. And on start, we could probably say TL is equal to get component trajectory line. And actually, I'm going to come here and I'm not going to make this public. It's just going to be one it gets itself. And then we're going to say TL dot render line, and we're going to say start point and current point, which is our end point. So now if we hit save and we go back to our game and we hit play, and I click and I drag, you'll see we've got the point of our trajectory. Problem is though, it is staying when I let go. So although we've let go of the trajectory, it's still showing this line on our screen. So that's what the end line was going to be for. So let's reopen our trajectory line script and let's create a new function called end line. This is going to take no parameters, but it's going to say lr.position count is equal to 0. And that's all it needs to do. So it basically just needs to set the count to 0, so it removes the 2 points which are there. We could also, there's many ways you can do this. You can deactivate the actual line renderer, which probably won't help too much, but you could do a lot of different things. Now we've got that, let's go back to drag and shoot. And now when we get our mouse button up, we want to say TL for our, or LR, is it? No, it's TL dot end line. And that is going to call once we let go. So if we go into our Unity again and we click on the play button, we're back in the scene. So now if we drag and we shoot, and we drag and we shoot, our line disappears after we've shot. You could also do other things. So the more you drag, so the longer it is, the different color it changed to and stuff like that. So just an indicator of how much power you're using and stuff like that with the line, which is pretty awesome. But we're not going to go over that in this video. So I hope you enjoyed the video. If you did, don't forget to leave a thumbs up. If you want to see more, then don't forget to subscribe and drop all your feedback and comments down in the comment section below. Finally, don't forget to go check out the devlogs. I'm making basically the game you saw at the start of this in Unity, and it's been pretty fun so far, and I'm going to be doing a lot more of it. So I make those weekly, and you can see those every Sunday. Thank you for watching, and peace out.